Good day. Welcome to our presentation about substitution rule for definite integrals in basic calculus. We are Group 1 from Grade 11 Leibniz.
So for our example 1, interval from 0 to 1 and integral of x plus 1 cubed dx. So first kunin muna natin yung y. So ang y natin is x equals x plus 1. So kunin natin yung derivative ng x plus 1 which is magiging 1 dx. So pwede natin sabihin is na yung dx is equals to dy. So kunin naman natin is transform boundaries. So if x equals 1, then y 1 plus 1 is equals to 2. So isa namang interval is if x equals 0, then y 0 plus 1 is equals to 1. So i-plug lang natin yung bago nating boundaries, then ilagay natin dun sa equation. Magiging interval of 1 from 1 to 2 y cubed dy, tapos kunin lang natin yung integral nun, magiging 1/4 times y to the 4th power. Lagay lang natin yung interval dun sa y, then ang magiging sagot natin is 3.75. So next example naman is interval from 0 to 1 integral of x minus 2 cubed dx. So kunin din muna ulit natin yung y which is x minus 2, then kunin natin yung derivative nun which is dy is equals to dx ulit. So pwede natin sabihin is na yung dx ay equals ulit sa dy. So i-plug lang natin yung interval din sa x, then if x equals 1, then y is equals to 1 minus 2, therefore y equals to negative 1. If x equals to 0, then y 0 minus 2 is equals to negative 2. So yun yung ating bagong transform boundaries, negative 1 and negative 2. So from interval from negative 2 to 1, y cubed dy, kung natin yung antiderivative 1/4 y to the 4th power. Lagay lang natin yung bagong boundaries dun sa equation. So ang magiging sagot natin is negative 3.75.
So for the problem number 3, we have the problem of integral of x square root of quantity x minus 1 closed quantity dx as x goes from the 0 to 3. First, we need to get the value of u, which is equal to x plus 1, du equals to dx, and x is equal to u minus 1. Then we need to adjust the integral boundaries and expand it. Now, we can apply the sum rule and solve for the problem, and we will get the answer of 116 over 15.
So for example number 4, the given is the integral of x squared times square root of x cubed plus 1 from 1 to 2. So first, we must get the values of y, which is x cubed plus 1. Next, we will get the derivative of y. This gives us 3x squared dx. Then, we will get the value of dx, that is equal to dy over 3x squared. Next, we will get the transform boundaries. So if x is equal to 1, then y is equal to 2. The other one is if x is equal to 2, then y is equal to 9. Next, we will evaluate the new integral, which is 1 over 3 integral of y cubed. Then we will use FTOC and substitute the values of our boundaries. This will give us 5.371.
So now let's go to example number 5, and we have the problem the definite integral of x squared times the quantity of 1 plus 2x cubed raised to 3 dx from 0 to 1. So we need first to identify the value of y, then we have the value of y is equals to 1 plus 2x cubed. Then to get the value of dy, just get the derivative of dy, and then we'll have dy is equals to 6x squared dx. Then to get the value of dx, just divide both sides by 6x squared. Then we'll have dx is equals to dy over 6x squared. Then we need to find the value of our transform boundaries. So the value of our x is equals to 1, then substitute it to 1 plus 2x cubed. Then we'll have y is equals to 3, and if the value of our x is 0, substitute it to 1 plus 2x cubed, then we have the value of y is equals to 1. So now we can use it to solve the problem. So just replace 1 plus 2x cubed by y, so we'll have y cubed and 1 over 6 dy. Since our value of dx is equals to dy over 6x squared, just cancel the x squared, then we'll have 1 over 6 and then dy. So now let's take out 1 over 6 and the integral of y cubed dy. So now let's get the antiderivative of y cubed, then we'll have 1 over 6 times the quantity of y to the 4th power over 4 from 1 to 3. Then we will use FTOC to solve the problem. Then we have 1 over 6 times the quantity of 3, which is the value of our y, raised to 4 over 4 minus 1, which is also value of our boundary y, 1 raised to 4 over 4. Then just substitute 1 over 6 times the quantity of 81 over 4 minus 1 over 4. And then subtract these two, then we'll get 80 over 4 multiplied by 1 over 6, we'll have 80 over 24. Then get the lowest term to get the final answer of 10 over 3.
For the last example, evaluate the definite integral from 0 to 1 of x times the quantity of x squared minus 1 quantity raised to 3 dx. So first, let's define the values. Y is x squared minus 1, dy is 2x dx because the derivative of x squared is 2x. Divide both sides by 2x and we will have x dx equals 1/2 dy. Next, let's find the new boundaries. So, if x is 1, then y is 1 squared minus 1 equals 0. If x is 0, then y is 0 squared minus 1 equals negative 1. Moving on, let's input the given values and we'll have the definite integral from 0 to 1 of y cubed times 1/2 dy. Combine 1/2 to y cubed, and since 1/2 is constant with respect to y, 1/2 will be moved out of the integral. Next, by integrating y cubed, we will have 1/4 y to the 4th power. And now, we can evaluate 1/2 times 1/4 y to the 4th power using the new limits we have solved earlier. Solve 1/2 times the quantity of 1/4 times the new value of b, which is 0 to the 4th power, minus 1/4 times the new value of a, which is negative 1 to the 4th power, and we will get our final answer, negative 1 over 8.
Okay, and that wraps up our discussion. Again, we're Group 1 of Grade 11 Leibniz, and thank you for listening.